A review of measurement. Today we're going to be looking at a review of scientific notation, a review of standard notation, one-step conversion reviews, multiple step conversions with 1 unit, multiple step conversions with 2 units, significant figure review, calculations with significant figures, and finally a review of accuracy and precision. Okay, so the first thing that we're going to do is review scientific notation. So we're going to convert the following numbers in standard notation into scientific notation. Now, what do we mean by standard notation? That means basically there is no times 10 to these, there's no little e's, they're just in their full form. So if I was to take this first one, it's 24,500. Now remember, the general format for scientific notation is that you are going to have a number in the ones position, you are going to have a decimal, and then typically 2 spots after the decimal, but that is really going to depend on the number of significant figures you have in your number. And then I like to do the times 10 to the, and then your exponent up here. Now, I always get into a debate with my husband, who is an engineer, and he likes to say, well, you can have a number in the ones position, a decimal, following numbers afterwards, and then put the e, and then whether the exponent is positive or negative, and then the number like it shows up on your calculator. Really, I think it all depends on what your teacher tells you to do. In my class, I will accept either, but I must admit, I'm more partial to this format. So again, let's look at our first number, 24,500. So I look at this number is greater than 1, so this 2 is going to be the number in my ones position. So I'm going to have 2.45 times 10 to the, and because it is a positive number, my exponent will be positive, so this is going to be 10 to the 4th. Let's look at the next one. We have 356. Again, the number that's going to be in the ones position in my format is going to be 3. So 3.56 times 10 to the 2nd. Please do not say 3.56. It's not 56. It's 56. 56 is a different number. So the correct response for this is 3.56 times 10 to the 2. The next number is smaller than 1, which means our exponent up here will be negative. So if I start over on the left and I go across, the first number that I see is the 9. So the 9 is going to go in my ones position, and then point, I'm going to take the 8, 5 afterwards, multiplication sign, and number 10. And then I'm going to start counting. I'm going to go from the left to the right, and I'm going to start at my decimal, and I'm going to say 1, 2, 3, 4 spots after the decimal. So that is going to be 10 to the negative 4. Now, why do we even use scientific notation? We use scientific notation to represent either very large numbers or very small numbers in a reasonable format. Because really, nobody wants to write zeros. Let's be honest with ourselves. Let's look at the next one. Again, this number is less than 1, so our exponent is going to be negative. So 0.222. This first 2 is going to be in the ones position. So 2.22 times 10 to the negative 1. Now let's go in the opposite direction. We are given scientific notation. Let's put it into standard notation. So 4.2 times 10 to the 3, that 3 is positive, which means this number is going to be larger than 1. So I'm going to basically take my decimal and I'm going to move it over 3 spots. So 1, 2, 3, and each of these spots right here are going to be filled in with zeros. So that's going to be 4, 2, 0, 0. Don't put a decimal at the end because we are not sure that it is exactly 4,200. So no decimal. Let's look at the next one. 2.15 times 10 to the negative 4, which means this number is less than 1, which means when we move this decimal, we are going to be moving it to the left. So if I did that, that'd basically be 1, 2, 3, 4, going to run out of room, and then our new decimal would be there, and we're going to fill in these spots with zeros. So I'll put a 0 in the front as a placeholder, and then put my 3 zeros in. So decimal 1, 2, 3, 2, 1, 5, representing this number in standard notation. Let's look at the next one. 3.14 times 10 to the negative 6. Again, that negative 6 tells us that it's going to be less than 1. So we're going to be moving our decimal to the left. So if I look at this, I'm going to have 5 zeros in front of that 3. So I'll put a 0 in the front as a placeholder. So 0 and then decimal, then 5 zeros. 1, 2, 3, 4, 5, 3, 1, 4. And our last one, our exponent is greater than 1, which means we're going to move our decimal over to the right, and we're going to move it over to the right 5 spots. So I'm going to say 9, 2, 2, and then we will have 3 more zeros. So 1, 2, 3. And that is a little reminder of how to go from scientific notation to standard notation. Now, let's get into some dimensional analysis. So important to know how to do this. I give you some conversion factors up at the top. 1 meter is equal to 1.094 yards. 1 mile is equal to 1,760 yards. And 1 kilogram is equal to 2.205 pounds. These are known as exact numbers, which means when we do our conversion factors, we are not going to worry about them in terms of significant figures. So whenever you are doing dimensional analysis, the first thing that you do is write down your given with the unit. So if I look at this first one, it's 1,500 yards to miles. So 1,500 yards. That is always the first thing that I do. And then I'm going to put a multiplication sign and a line. Whatever unit I start with will go on the bottom. Whatever unit I want, which in this case is miles, will go on top. So yards on the bottom, miles on the top. And then I look up at my conversion factors because I don't expect you to memorize these. And this says that 1 mile is equal to 1,760 yards. So 1 mile is equal to 1,760 yards. And I know that I have this set up correctly because yards will cancel yards. I am left with miles, which is what I want. So then I'm going to do 1,500 times 1 divided by 1,760. And when I do that in my calculator, I get 0.8522 miles. But is that to the right number of significant figures? So remember, when you do this, what you want to look at in terms of significant figures is your given. So here's my given. My given only has 2 sig figs. Only 2 significant figures. That means my answer can only have 2 significant figures, which means I'm going to count the 8. I am going to count the 5. So my final answer here is going to be 0.85 miles, taking into account significant figures. Let's look at the next one. 34 kilograms into pounds. So the first thing I'm going to do is write 34 kilograms, multiplication sign in a line. I am going to put kilograms on the bottom. I am going to put pounds up on the top. And then I am going to look for my conversion factor. This says that 1 kilogram is equal to 2.205 pounds. So 1 kilogram, 2.205 pounds. And now what we are going to do is make sure that we have set this up correctly. Kilograms cancels kilograms. I'm left with pounds, which is what I want. I am going to do 34 times 2.205. And when I do that, out pops in my calculator 74.97 pounds, roughly. Now again, I need to think about significant figures. So when I do significant figures, I look at my given. My given is 34. That's 2 significant figures. So when I go to my answer, I'm going to look at the 74, but I'm also going to look at the 9 after the decimal because I will round up. So because I'm going to round up, the correct final answer here should be 75 pounds. 75 pounds should be my final answer. All right, let's do one more in our one-step conversions. I have 34 pounds to start with. Multiplication sign and a line. Pounds are going on the bottom. Kilograms are going on the top. Again, I know that 1 kilogram is equal to 2.205 pounds. I am going to make sure that my units are set up correctly. So pounds cancels pounds. 34 times 1 divided by 2.205 is going to give me 15.49 kilograms. And then I'm going to think about rounding. Now, technically, because this is 0.4, I'm going to round down. So I'm going to have 15 kilograms as my final answer. And it's going to be 15 because, again, I have 34 to start with, which is 2 significant figures. Therefore, my answer needs to end in 2 significant figures. Let's go on to multiple step conversions with 1 unit. Again, I am giving us some conversion factors here. 1 meter is equal to 1.094 yards. 1 mile is equal to 1,760 yards. 1 meter is equal to 3.28 feet. So I am going to start with 30 meters to miles. So the first thing I'm going to do is write down my given. So 30 meters. And then I have to start thinking about how I'm going to plan this out, because I know that if I start with meters, meters is going to go on the bottom. And there's nothing here that gets me directly to miles, but I do have 1 meter is equal to 1.094 yards. And over here, I have yards going into miles. So most likely, I am planning for a 2-step conversion. So I'm going to start by using this conversion right here. 1 meter is equal to 1.094 yards. Another multiplication sign and a line, because I look at this and I say, all right, meters are gone. Meters cancel meters, and now I'm in yards. But I don't want to be in yards. I want to be in miles. So on the bottom here, I'm going to write 1,760 yards is equal to 1 mile. Dot. 1 mile. And again, yards cancels yards. I'm left with miles, which is what I want. So now I'm going to say 30 times 1.094 times 1 divided by 1 times 1,760. And if I work that out in my calculator, I will get 0.01864 miles, or something roughly like that. Now, I can't have that many significant figures, because if I look at the beginning here, in the beginning, I only have 1 significant figure, which means if I go across, this is my first significant figure. So I'm going to round up. I'm going to round the 8 up. So my final answer here to 1 significant figure is going to be 0.02 miles. That will be my number of significant figures. Let's try this next one. 15 micrometers. You should remember the prefix micro from your summer assignment. Micrometers to inches. All right, so 15 micrometers. And I don't give you that conversion because I actually expect you to know that. I'm going to convert to my base unit of 1 meter. So I know that there is 1,000,000 micrometers. And I'm going to write the zeros out for giggles. So 1, 2, 3, 4, 5, 6. So that's micro. Another multiplication sign and a line. And again, I'm going to check myself. Micrometers cancels micrometers. I'm left in meters. But I don't want meters. I want inches. So I know that I can look up here and say, hey, I have 1 meter into 3.28 feet. I can get to inches from there. So if I start with meters, meters needs to go on the bottom. Feet need to go on top. So 1 meter is equal to 3.28 feet. Again, meters cancels meters. And then I go on to my last conversion where I need to get to inches. So feet will go on the bottom because I want to cancel that. and inches will go on top. And you should know that there are 12 inches in 1 foot. Final cancel of units, so feet cancels feet. I am left with inches, which is what I want. So now I'm going to say 15 times 1 times 3.28 times 12 divided by basically 1,000,000. So if I put that into my calculator, I get 5.904 times 10 to the negative 4. In mine, it came out in scientific notation. In yours, it might come out in standard notation. Either way is fine. But now we have to consider significant figures. So I have 2 significant figures to start with, which means I'm going to take the 5 into consideration. I'm going to take the 9 into consideration. The 0, 4, I'm going to disregard. So my final answer here will be 5.9 times 10 to the negative 4 inches. All labeled to the correct number of significant figures, which is definitely important. Multiple step conversions, working with 2 units. So now we really need to think about how are we going to set up our given. So this is 20 kilometers per 1 hour. Remember, there's an assumed 1 right there. So when you set these up, it's going to be 20 kilometers per 1 hour. And if you write it like this, it's much easier to work with a 2-unit conversion factor. So multiplication sign and a line. Now I want to get to meters per 1 second. So I need to decide which unit am I going to convert to first. I think I'm going to work with the meters first. So I know that in 1 kilometer, there is 1,000 meters. And if I do that, I could see that kilometers cancels kilometers. I'm left with meters, which is what I want at the end. So technically, I'm done with that particular conversion. Now what I need to do is I need to get from hours to seconds. So I'm going to put another multiplication sign, another line. Now hours starts on the bottom of my conversion factor. So that means the hours needs to go up here in order for them to be able to cancel. I want to get to seconds. So I'm going to take the long way and I'm going to put minutes on the bottom. So I know that in 1 hour, there is 60 minutes, and then I'm going to do one more conversion factor, and in 1 minute, there is 60 seconds. 60 seconds. Now, I need to go through and make sure that all my units cancel, and I am to the proper units at the end. So 1 hour cancels 1 hour, minutes cancel minutes, and seconds is where I want to be at the end. So now I have my proper units, minutes over seconds. So now I'm going to say 20 times 1,000 times 1 is divided by 60 times 60. And when I do this, if I write my answer out that I get in my calculator, it's 5.55 meters per second. Again, I have to think about significant figures. This 20 here is only to one significant figure, which means my final answer here is going to be 6 meters per second, because I will round up these 5s and affect this first 5 right here. So 6 meters per second is my final answer. Let's do one more. 45.0 feet per 1 minute to yards per day. So the first thing I'm going to do is set up my conversion factor. So 45.0 feet per 1 minute. Per 1 minute. Now I need to get to yards, and we can go back and we can think about our conversion factors. So if I want to get to yards, I know that in 1 yard there is 3 feet. I just know that, and that means that feet cancel feet, and I'm left with yards, which is where I want to be. Now I have to go back and deal with the time issue. So 1 minute, and I need to get to 1 day. All right, so if minute starts on the bottom, that means I'm going to put minute on the top. So I'm going to go from minute to hour. So there is 60 minutes in 1 hour, and then I'm going to get rid of the hour unit because, again, I want them to cancel each other, one on the top and one on the bottom. And in 24 hours, we have 1 day. So now I can say minutes cancels minutes, hours cancel hours. I'm left with my final unit, which is days. So since I have the proper units now, I can do 45 times 1 times 60 times 24 divided by the collective 3. And again, if I put that into my calculator, I get for my answer 2.16 times 10 to the 4th yards per day. And if I look at, I can keep it just as it is because I start with 3 significant figures and here I end with 3 significant figures. And of course, if you're more comfortable, you could keep it in standard notation if you want to. I'm just more of a fan of scientific notation. To me, it looks a little bit more organized. All right, we've been talking a lot about significant figures here. So if you have forgotten about significant figures and how to figure them out, a little reminder. I like using the Atlantic-Pacific rule in terms of the decimal. If a decimal is present, you are going to start at the left-hand side or the Pacific side, and you're going to go across until you find your first non-zero number, and then every number, including that non-zero number, will be significant. If the decimal is absent, we start over on the Atlantic side, otherwise known as the right side, and we go across until we hit our first non-zero number, and then every number, including that non-zero number to the right, is significant. So what do I mean by that? So here's my first number, 0.048. The decimal is present. It is right here, which means I'm going to start on the left-hand side, and I'm going to move across until I hit that first non-zero number, which is 4. That means the 4 and everything after it is significant. Therefore, in this situation, we have 2 significant figures. Here's my next number. You will notice that the decimal is absent, which means I'm going to start over on the right-hand side, and I'm going to go across until I hit my first non-zero number, which is 7. So the 7 and everything continuing on towards the left will be significant. Therefore, here I have 3 significant figures. And that is a little review of how to determine significant figures if you're given a number. So let's do some practice here. Determine the number of significant figures in the following numbers. So I look at this first number, 250.7. This 0 here is surrounded by non-zero numbers, which means that everything's basically significant. So the answer here would be 4. In this next one, the decimal is present, which means I'm going to start on the left-hand side. I'm going to go across until I hit the first non-zero number, which is 7. And then that number and everything past it will be significant. So there is 2 significant figures here. This 0 is surrounded by non-zero numbers, so that means this is going to be 4. This number is set up in scientific notation, which is a perfect way to look at it. Nice and easy. There are only 2 numbers involved. None of them are zeros, so here is 2 significant figures. In this number, the decimal is absent, so I'm going to start over on the right-hand side. I'm going to go across until I hit my first non-zero number, which is 4. So everything, and as I continue over to the left, will be significant. So that means there are 2 significant figures here. For the next one, the decimal is present in the number, which means I start over on the left-hand side, and my first number is a non-zero number. So that means that number and everything after it, including the zeros, is significant. So therefore, I have 4 significant figures here. In the next one, again, a decimal is present, so I'm going to start going across until I hit my first non-zero number, which is 2. So the 2 and everything after it, including the 0 that's surrounded by other non-zero numbers, and the 0 at the end, is significant. So if I count this up, I will have 6 significant figures. 1, 2, 3, 4, 5, 6. Same situation down here. A decimal is present. I'm going to go across until I hit my first non-zero number, which is 3. That 3 and everything past it is significant, which means there are 4 significant figures here. Hey, look at same situation. Decimal is present. So the 3 and everything going over, including that trailing 0 at the end, is significant. So that means I'm going to have 5 significant figures here. And the last number is just sort of a gimme because there's no zeros. So everything is significant. Therefore, there are 2 significant figures here. Using a calculator, carry out the following calculations and record the answer to the correct number of significant figures. Okay, so we have a couple of things going on here. We have situations where we are multiplying, situations where we are dividing, situations where we are adding, and of course, situations where we are subtracting. There are 2 sets of rules that we need to follow when doing calculations with significant figures. When you are dealing with a situation where you are multiplying or dividing, we are looking at the lowest number of significant figures as our answer, and we'll go through that. When you are adding and subtracting, it's all about decimal points because remember, for any mathematical computation, the answer should not be more precise than the least precise measurement in the computation. Translation, got to think about how many decimal places you're going, and we'll see that in a moment. So let's look at our first one. We have 34.5 times 23.47. If I look at this, I can say, all right, this has 3 significant figures, and this has 4 significant figures. So when I figure this out, my answer can only go to 3 significant figures. When I plug this into my calculator, I get this answer, 809 point. And again, let me reiterate, this is 0.37, not 0.37. That's, well, frankly, wrong. Okay, so this is my answer. So I can only go out 3 significant figures, which means I'm going to take my highest numbers, which is 309. I look past the decimal. The 3 is less than 5, so my final answer here is 809 is my final answer. Let's go on to this one. 123 divided by 3. I have 3 significant figures here. I have 1 significant figure here. When I work this out, I get 41. Now again, I can only have 1 significant figure because I'm dividing. So that means I'm going to keep the 4, but I'm going to replace the 1 with a 0 as a placeholder. So my final answer here for this one is 40. The next one, 2.6 times 10 to the negative 1. This is a little weird, so we think about this in terms of scientific notation, times 356. So when I look at this, the 2.61 is all I'm looking at in terms of significant figures. So we have 3 significant figures here. We have 3 significant figures here. So we are going to multiply these 2 together. When I do that, my answer is 92.916. So when I work this out, I'll keep the 9, the 2, the point, the 9, and then I'm going to round down the rest of the way. So my final answer for this one is 92.9 to 3 significant figures. Alrighty, let's go on to the next one. I have 21.78 plus 45.86. Now this is addition, so I am actually going to rewrite this so my decimal points line up because it's much easier to see what I have to do here. Now, again, for any mathematical computation, the answer should not be more precise than the least precise measurement in the computation. So this first number goes out 2 decimal places, the second number goes out 2 decimal places, which means my answer can only go out 2 decimal places. I'm not really concerned about the number of significant figures here. I'm worried about the numbers after the decimal places. So when I add these 2 together, I get 67.64. And that's my final answer for this one. Again, I'm not worried about significant figures. I just have to make sure that I don't go farther than 2 decimal places. Let's look at the next one, which is a pretty good example of what I mean. The first number is something ridiculous of 23.88887 minus 11.2. When I do this, even though this first number goes out a ridiculous 6 decimal places, my second number only goes out 1 decimal place. So that means no matter what, my final answer can only go out 1 decimal place because I don't know what's going on over here, nor can I predict. So when I subtract these two, I get 12.6888897. But again, I can only go out one decimal place. So I will take the 8 into consideration and round up. So my final answer for this one is going to be 12.7. And then finally, the last one on this page, 6 minus 3.0. Again, I have really no idea what's going on here. So I subtract these two. It's going to be 3 for my final answer because, again, I can't predict what is past this 6. I can't be more precise than my least precise measurement. Let's carry on. 32.559 times 34.555. Again, we're back to multiplying. So I look at this and I say we have 5 significant figures here. We have 5 significant figures here. So when I put this into my calculator, I get 1,125.076245. But again, I can only have 5 numbers in my answer. So I'm going to take these 4 and I'm going to take the decimal and the 0, but I have a 7 here, so I'm going to round up, which means my final answer for this one is going to be 1,125.1. Going on to the next one, 1.2 times 4.3. So this is 2 significant figures. This is 2 significant figures. If I multiply these two together, I get 5.16. I can only have 2 significant figures, so I will take the 5. I will take the 1. I will round up the 6. So my final answer here is going to be 5.2. Let's look at this one. I have 8.08 plus 21.98. Both numbers are only going out 2 decimal places. So when I add these together, I get 30.06. And that will be my final answer for this one because I have gone out the correct number of decimal places. And finally, the last one, 4,433 minus 1,187. And if I take the difference of those two, I get 3,246 for my final answer. So this is a basic review of how to do multiplication and division, adding and subtracting with significant figures. We will go into this in more detail as we get farther along in the AP Chemistry course. Finally, let's talk about the difference between accuracy and precision. Accuracy refers to how close the measured value is to an actual value, and precision refers to how close a series of measurements are to one another or how reproducible they are. We are going to look at this example to help us see that. Consider 3 sets of data that have been recorded after measuring a piece of wood that was exactly 6.000 meters long. So this is our standard. We have set X, 5.864, 5.878, 5.871 meters. We have set Y, 6.002, 6.004, and 6.003 meters. And finally, set Z, 5.872 meters, 5.868 meters, and 5.870 meters. Which set of data is the most accurate? And remember, accuracy refers to how close the measured value is to the actual value. If you said set Y, you are correct because these values right here are closest to our standard. The next question asks, which set of data is the most precise? Again, if you said set Y, you are also correct because these values are the ones that are closest to each other, while there are major differences in the numbers between set X and set Z. So what did you learn? We looked over a review of scientific notation. We looked over a review of standard notation. We did some one-step conversion review. We did multiple step conversions with 1 unit, multiple step conversions with 2 units. We did a big significant figures review. We did some calculations with significant figures. And then finally, at the end, we did a review of accuracy and precision. Need more help? Feel free to contact me. Have a great day.